Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. And today we are doing series and parallel circuits in physics. So this is chapter 23 in the physics book if you're following along as a class. And this would be a series circuit, because you can see that the electricity only has one path to go through to get where it wants to go. And these are the formulas. You add up the resistances if it's a series circuit like this. So resistance equals R1 plus R2 plus R3. Now I call this resistance total, R tot, okay? So here's our first example problem. And we also we'll use this formula, current equals voltage over resistance. Example 1. 4 15-ohm resistors are connected in series with a 45-volt battery. What is the current in the circuit? So that's what we have so far. So current is voltage over resistance, and our total voltage is 45, 15 times 4, and our resistance is 60. I said that backwards. I'm like, something's wrong here. This isn't adding up. Because 15 times 4 is 60. That's our resistance. That's our voltage, 45. So you divide them, and it's 0.75 amps. All right, pretty easy math. I like this math. Okay? Now, voltage drops in a series circuit. We have a formula for that. And so let's look at how we use it. A 45-volt potential difference is placed across a 5-ohm resistor and a 10-ohm resistor connected in series. So what is the equivalent resistance of the circuit? So first of all, we get our total resistance is 5 plus 10 is 15. Okay, that's question 1. We did all right for that. What is the current through the circuit? So voltage equals current times resistance. 45 is current times 15. Divide both sides by 15. Current equals 3 amps. All right, got part B done. C. What is the voltage drop across each resistor? For each one, we're going to multiply the current times the resistance. Resistance. 3 times 5 is 15. 3 times 10 is 30. Okay, next one. What is the total voltage drop across the circuit? Voltage total is equal to the voltage added up. So 15 plus 30 is 45. 45 volts. See, these are fun problems, aren't they? They're simple and pretty fun. All right. Oh, here's our problem right there. I'm like, here's the work, where's the problem? There it is. A 9-volt battery and 2 resistors, one at 400 ohms and the other one at 500 ohms, are connected as a voltage divider. What is the voltage across R2? So there's our little situation. Oh, it's hard to see there in the shadow. There's our little situation. And now this is how we're going to do the math. So we're given 9 volts, 400 ohms, and 500 ohms. So to get V2, it's V2 times R2 over R1 plus R2. So 9 times 500 over 400 plus 500 is 5 volts. All right, that one's not bad either. I'm seeing if we could do that. No, that Pocket Lab's too hard. All right, so this, now it changes. Let me turn back over here. If it's parallel, we have different formulas. I is still V over R, but if it is parallel, instead of just adding up the resistors, it's the inverse. It's 1 over. And the current you just add up. So here's our problem, problem number 4. 3 resistors of 60, 30, and 20 are connected in parallel across a 90-volt difference in potential. Find the equivalent resistance. Oh, seeing if I did the work somewhere. Nope, I guess we're just going to look at their work. I guess it was pretty simple, so we just had to put it in. where were we? Find the equivalent resistance of the circuit. So you put 1 over each one of these and add them up. And you can do this on your calculator. Normally, you know how you have to have the same denominator for to add fractions, but if your calculator's doing it, you can get the answer, and it is 10. All right? Next part. Find the, and I guess I should show you, on your calculator, when you're adding up fractions, you either have to put them in parentheses, so like it would be 1, let me go back here. It would be beginning parentheses 1 divided by 60 in parentheses. Then we could do plus beginning parentheses 1 divided by 30 in parentheses, plus beginning parentheses 1 divided by 20 in parentheses, and we can get our answer that way. Or you can use alpha y equals and then hit enter, and that makes it a fraction where you could do 1 over 60 arrow over plus. So I like the alpha y equals option, but let's give it a glare there because it gives nice little fractions there. See that? Or you can use parentheses. But if you try to do it without parentheses, you'll probably get the wrong answer. All right. So anyway, that ends up being 6 over 60, which is 10 ohms. Okay, the next part is we have the voltage and the resistance, and we want the current, so we just divide them. And the next one is the voltage dropping across each one is 90. So what are the currents? So for each one, you fill in 90 for the numerator and the resistance for the denominator, and you get 1.5, 3, and 4.5 amps. All right. Not hard. Let's see what else we got here. I think that might be all the math. You can look at this, but this is going to be optional when where it mixes series and parallel. That's not anything we're going to worry about. All right, yep, so that's it. Like, share, subscribe, and come back and we'll do our last chapter for this class. Woohoo!